routing. Okay, we also have learnt about routing information protocol and OSPF as part of intra-autonomous routing. As I promised today, we'll talk about the inter-autonomous routing, which is very, very crucial. And you can say this is very, very important protocol when you talk about the internet application, right? So border gateway protocol is going to be discussed by us in this short period of time. Let's proceed. So at present, we have got the BGP version 4, Border Gateway Protocol version 4. And what does it exactly provide? It provides the autonomous system some capabilities. You know what is an autonomous system? The set of network or a network which is governed by a single administrative body. We have spoken about this enough in the last session about the autonomous system. So what does the capability BGP provide to these autonomous systems? There are many, but to name, to put them in an abstract way, I have got some 3 points. One is to obtain the reachability information from neighboring autonomous systems, right? So you have got 2 or 3 or 4 autonomous systems interconnected. Now it is the BGP who is having the responsibility to get the subnet reachability. In other words, routing information. All right. So the subnet reachability information from the neighboring autonomous system is taken by BGP. You are not having any other protocol to replace this. And to propagate the reachability information to all the routers internal to BGP, internal to the autonomous system. This is second important one. Okay, when you get the reachability information from other autonomous system, you also have the responsibility to give those information to all your internal routers within your autonomous system. BGP does that, and it also helps you to find the optimal path or the preferred route, in other words, good route to subnets based on the reachability information and the autonomous system policy. The reason is every of the autonomous system, as I have mentioned earlier, is having its own policies, right? So whether to accept the packet or to prevent the packet, can the internet be connected, or whether this website is permitted, all these are coming under policy, right? So abiding by the policy, now it is the responsibility of BGP to find the good or the optimal route to reach the destination. So this is in a nutshell what BGP is actually providing. But on the other hand, BGP is a complex protocol, right? So it's not very easy. People say you have got separate books. So if any of you are interested, again, I would recommend you to read Internet Routing Architecture. Okay, there is the subject also offered in our department as an elective. So Internet Routing Architecture is a very good book by the Cisco Press to know about border gateway protocol. So those who are interested can start reading that textbook. Very informative and high technically rich content are available in that textbook, in that book for that matter. All right. So some of the basics, as I said, BGP is extremely complex, right? And we are going to use the topology which is on the screen to learn further about the BGP, right? So what happens here, what's given here, this is a known topology for us. We have already spoken about this topology earlier. You have got 3 autonomous systems. They are autonomous system 1. Just hold on. Yeah. So they are autonomous system 1, which is here. You have got autonomous system 2, and you also have got autonomous system 3. Right. Now this autonomous system 3 is having a 3A. The name of the router is 3A, which is the border protocol, border router. In other words, the gateway router. Right. So this router connects with 1C, which is another gateway router available in autonomous system 1. This autonomous system has got another gateway router to connect with autonomous system 2. That is 1B is connected with 2A, right? So now when you talk about the BGP, there are the routers which are called 1B and 2A. They are called as BGP neighbors. All right. So when the routers are having the direct connectivity, they are called as BGP neighbors. And again, 2A is having connection with 2C, BGP neighbors, and so on. So again, 1C has got a mesh connection with all the other protocol. And again, for that matter, autonomous system 1 has got a mesh connectivity. So hence, 1D is connected to 1C. They are neighbors. But on the other hand, You have got BGP using TCP, Transmission Control Protocol, in port number 179. Okay, so once these BGP neighbors are able to establish a BGP connection or a TCP connection, then they are called as BGP peers. All right. So these two, once they have completed their TCP handshaking for BGP communication, they are called as BGP peers. Till then, they are called as BGP neighbors. All right. So they go for handshaking protocol to have the connection with them. Right. Moving on. Continuing that, BGP allows each autonomous system to learn which destinations are reachable via its neighboring autonomous systems, right? So for that, I go back to this screen. You have got autonomous system one. This autonomous system one has got two border routers, and these routers are gateway routers. These gateway routers are interacting with the BGP of the other autonomous system too, and it gets the reachability information from them. Now, the point of concern is when you talk about autonomous system, don't think this is a router. This is a collection of network, okay, collection of routers. You can assume this as probably a class in your Java, right? You can have multiple objects, right? So an object can have multiple variables and functions, X, Y, Z. So when you talk about the autonomous system, it has its own number of routers, because sometimes when you learn about autonomous system, we may be tempted to assume that it is a router. No, it's a collection of router, right? Now, when you have the collection of routers here and here, and when we call them as the autonomous system, when they establish the connection, no, 1B has made a BGP peering, BGP peering with 2A. Now, these two communicate each other to get the reachability information. So 1B gets the reachability information about other networks in autonomous system through 2A. I repeat, through 2A, this gateway router, 1B gets the reachability information of all the networks of this autonomous system, all the other networks of this autonomous system. Similarly, the story continues here through the router 3A. Once it gets it, and it redistributes. And again, autonomous system 1 also has got n number of networks within it. So this reachability information also will be shared. Now there is a trouble. Is it as easy as you are thinking? Certainly no, right? What exactly happens? You are having n number of such networks within it. So you cannot advertise. And again, if you look at the host, that is numerous. So you have to, you let us not worry about the host, but let's bother about the networks, because every of the networks should be reachable from other networks. That's the primary objective, right? So we have spoken about this in the earlier class. When you talk about the administrative autonomy, you are supposed to make the connection to be established between end-to-end machines. So having that in our mind, if this autonomous system assume that has got 100 networks, if all the 100 networks are pushed, you should understand how much information one B router has to receive, and that has to be redistributed across the routers within the autonomous system. That is really going to burden the routers in the autonomous system, right? So for that, BGP supports your CADIAST prefix. You know about what is this prefix? In other words, we call it as summary network or super netting, right? So I'm not going to explain this calculation. It is known to you how we got this summary address. So in BGP, destinations are not host, certainly, but instead they are CADIAST prefixes, which is summarized prefixes, where each prefix representing a collection of subnet. Okay, so we have gone little up than our computer networks. It's a collection of networks we are talking about when we talk in the other side. So you can think about your object-oriented concept, where you have got the abstract, right? So the same logic. So a lot of things are inside, but you're telling outside only the autonomous system, or you are giving only the supernet or the summary address to the other side. So the four networks are given, are represented by a single network address, right? So that is again supported by your BGP. Then you should ask a question, then what will happen when there is a mismatch? Yes, you have to go for the longest matching, as you all are aware of. All right. Then other word which newly comes here is eBGP. So what is that eBGP? BGP would distribute the prefix reachability information using eBGP. What is that? Between the routers, okay, between the gateway routers. So going back to our topology, when you have router 1B established a connection, TCP connection for BGP exchange with 2A, this is called eBGP. Okay, external BGP, very simple. So don't you guess, when you have a connection between 1C and 1B using BGP, that's going to be IBGP. No wonder it is internal BGP, right? So these are the two keywords we are getting newly. So when you get the reachability information from other autonomous system, it is eBGP which is completing that task, okay, to your gateway router. Now, how does the gateway router give this reachability information through all its internal routers within its autonomous system? By using IBGP, right? So when a gateway router receives the eBGP land prefixes, yes, the gateway router uses the IBGP sessions to redistribute or distribute the prefixes to other routers in its autonomous system. All right, so you have got BGP running in two different modes. One is eBGP, the other one is IBGP. All right, so the clear discussions are available in the textbook which I have mentioned at the start of this class. All right, so next words or next topic which we need to know more about BGP is path attributes and also BGP routes. What is a path attribute? We are going to see that. So every autonomous system, before that, every autonomous system is given a unique autonomous system number called ASN. Very similar to how you are getting the IP address from IANN. All right. In the same way, your autonomous system should get autonomous system number which is unique in the internet. All right, given by such organizations, right? So it is uniquely identified. So autonomous systems are uniquely identified. When I say AS1, there cannot be another AS1 in the computer network, right? Second one, when a router advertises the prefix across the BGP session, we have just seen using the IBGP and using eBGP, the routers are advertising the routes, right? Very similar to your RIP and OSPF protocol. They also advertise the route to other routers. They don't only give the routing information, but also a number of BGP attributes, okay? And there are humpty number of BGP attributes, but we are going to talk about two primary or probably two important BGP attributes. They are autonomous system path and next hop. All right. What is an autonomous system path? In short, it is AS path. Routers use the autonomous system path attribute to detect and prevent looping advertisements. I'll explain to you with an example. If a router sees that its autonomous system is contained in the path list, it will reject the advertisement. All right, I'll explain this with an example. This is the topology I have again taken from the internet, but that gives the clear picture of what is the AS path attribute, right? So you have got 4 autonomous system on the screen in the topology connected together in a serialized way. Autonomous system 1000, AS1000 is connected to AS2000. In turn, it is connected to AS3000 and then it is connected to AS4000. So there is no mesh connectivity. It is a serial connectivity. All right. So when autonomous system 1000 or AS1000 in short sends the route advertisement to AS2000, this is called distribution of route. When this route is distributed, it includes its own ID. If I am the person who distributes the routing information to my neighbor, to the other autonomous system, to the gateway router in that autonomous system, I include my ID, the autonomous system number in that path attribute. Okay, so that is included. And then what is a path, by the way? Path is a collection of routers. We know, right? Connection of router which gives the routing information, right? So when this comes to autonomous system 2000, when that forwards the information to autonomous system 3000, it includes its own ID at the end. Okay, it is prefixing its ID. I'm sorry, it's not at the end, it is prefixing its ID. And then it goes to the next autonomous system. When it is forwarding, it is prefixing that ID. So you will understand that autonomous system 3000 is at the head of this list, from where you got the recent update, not from 2000 or 1000. It is from autonomous system 3000 you got the update. When you are redistributing the information, this AS path is going to help you a lot. So I'll take the same of our example here. All right. So when you have got autonomous system 3, 1, and 2, okay, 1, 2, and 3. Now autonomous system 1C, okay, autonomous system 1C has got a routing update through this 3A. Okay, this 3A, when it is giving, it gives this autonomous system ID also along with this, it comes to this 1C. All right. So when 1C is forwarding that information to 1B, don't you think eventually this also may come back here? Because it's all advertising, because they all use IBGP. When they are advertising, it goes to everyone. When it is coming to this advertise, when this router 1C looks at this its own ID in the autonomous system path, it understand, okay, this is not going to help me, and this is going to avoid, this is going to discard that packet. Not only that, this autonomous system, this gateway router in autonomous system 1 would update this would distribute this routing information to 3A. Now this autonomous system 3 will understand this is the information I have forwarded to you, it's going to reject it, because this is very important. The reason is every of the autonomous system may have their own routing policy and protocols, right? So this kind of stringent mechanisms are very, very essential, especially on the BGP protocol. The other path attribute is next hop. Okay, next hop is the router interface that begins the autonomous system path. Okay, what is the use of this next hop path? Yes, I'll again use the same topology so that you can understand it easily. All right, now assume that autonomous system 3 has sent a routing information, summary route, of course, right? Routing information has distributed routing information to 1C. Similarly, this autonomous system 2 routers also will send the routing information to autonomous system 1. Okay. When they are coming inside, when they are getting distributed among this autonomous system path, now these routers, when they are looking at the path, okay, when it sees the next hop interface, what is the next hop interface? Where am I supposed to forward the packet so that I can reach the destination? So once you get the have a packet to be forwarded to 2B, you clearly understand the packet has to be sent through this. So once you see this next hop, now you can easily understand the shortest path. Okay, so because we have something called hot potato routing, we know that. I will also talk about that in the next slide if I am correct. Okay, so it is very, very crucial for you to find the least cost path when you are forwarding the packet. So knowing the next hop information is very important for us. As we could see the whole topology in this network, we can easily understand, okay, this is the shortest path, that's the longest path, don't go through this way. But when you look at the routers, when they are blind enough that they can understand only from the packaging information which they are getting as the advertisement from other BGP peers, they need the next half information as well, all right, to find the correct path. Not only that, there is another reason why we have to go for next path. I have taken this example to explain to you. You have got the autonomous system 2. There are two routers. Don't confuse with the actual topology which we are seeing so far. Now you have got the routing topology information, redistribution of route in this direction, which is given in blue color. Okay, and you have got autonomous system 1. Assume that this router, okay, in autonomous system 1 is learning about route X. What is route to X? Okay, X is a router here. Okay, there is a destination here which is not shown here in AX2, which is the network here. So the route to X is given by this router to this router, and also by this router to this router. Now there are two pairs of links are coming here. Now there are two routes existing which are available with you. Now how are you going to send the packet? You go for the shortest path. Okay, least cost path, shortest path. That is what the hot potato routing, we know that. All right, now this router will choose this routing information to send the packet, because it has got the next hop information. Next hop is the IP address of this router. Please understand, every router has got more than one IP addresses, because it is all connected to more than one network. Okay, so there is IP here, there is IP here. So based on this next hop IP, this router will forward the packet through this link to reach the um, topology here, or the network X here. Okay, so this is the use of next hop, and we also have learned about autonomous system path. Okay, two important path attributes you should remember, though there are n number of other attributes available as well. Okay, there is another word called import policy. will you accept every of the routing information whichever coming from the other side? Will you accept everything? No. You can have your own policy whether to accept a routing information or to reject a routing information which are learned through the advertisement of the BGP pairing. Okay, so that is called import policy. Again, BGP supports it. As we started this class with this word, not only based on the best route, but also based on the policies of the autonomous system, right? Okay. Next, how do the BGP select the, how does the BGP protocol select the route when there is more than one route exists? Okay, more than one route is existing to the destination. How are we going to select the route? By using the elimination rule. There are 2-3 constraints. Nothing technical to explain to you, but we should know how a path is selected, how a route is selected by the BGP. Okay, routes are assigned a local preference value by the BGPs, which are not given in detail, but this is something very similar to your administrative distance in the other routing protocols. Okay, so local preference is set by the BGP peers. The routes with the highest local preference values are selected. That's the first one. Okay, so local preference value has got the highest priority, and again, when the local preference value is higher, then the route is selected. That is first one. All right, sir. After that, still there is a tie. Okay, more than one route is having the same high local preference value. So what shall we do? Okay, for all the routes with same local preference value, the route with the shortest AS path is selected. Now you should remember, you should understand the usage of the AS path attribute. Okay, the shortest AS path. So BGP goes for the shortest path route. Okay, shortest route. So that is the second condition to accept or eliminate a route. All right. And now to improve, not to increase the issue, there are more than one route. Okay, is having the same autonomous system AS path value. So what shall we do for all the routes with the same local preference and same AS path length? The route with the closest next hop router. Okay, this is for hot potato routing. Please remember, for hot potato routing, you should have the closest. So what is the hot potato routing logically? When you have the ISPs, these ISPs are trying to send their packet as early as possible to the other side. Simple. That's how you can increase the speed. All right. So that is called hot potato routing. Now the route with the closest next hop will be chosen so that somehow you push your packet to the other side. Don't carry everything on your head. Is the unwritten rule in ISPs. Okay. All right. If more than one route still is remaining, then the router uses BGP identifier to select the route. How BGP identifiers are chosen? Okay, but the BGP identifiers are generally the ID of every of the route. So based on the route, probably it may, it will choose its own based on its own policy. There is nothing a strong policy is given here. Okay, this is how BGP routes are selected. So lowest local preference is removed, and the highest autonomous system path is not considered. When you have the next hop having which is somewhere there, again you are not going to use it. Okay, so these are the criteria or the steps or the probably the rules for BGP route selection when you have multiple routes existing to the destination. Okay, something about the routing policy. Hope this is the last slide. Yes, so this is going to be your last slide today. What happens in a routing policy? I just wanted to give a simple example, right? So you have got a topology where there are 6 autonomous systems, right? The autonomous systems A, B, and C are the ISP autonomous system, and W, X, Y. These are all the customer side, okay, consumer side autonomous system. And in this example, autonomous system W, autonomous system Y, and X, these 3 are stub autonomous system. What is that stub autonomous system? They are having packets having only one path to the destination, to the autonomous system, which are connected. For instance, W has only one path to autonomous system A, Y has got only one path to autonomous system C, and X has got one path to C, and X has got one path to D. Though X is not the complete autonomous stub network, W, X, and Y, these 3 are the stub networks here, which means they are not going to come, they are not going to forward the packet towards through them to another network. That is called stub network, right? Okay, so in this topology, ISP networks A, B, and C have the responsibility of forwarding the packet. Okay, whereas the autonomous systems W, X, and Y, they don't have any liability to forward the packet because they are a customer network. Why should a customer network forward the ISP network? No, why should a customer network do that? So it doesn't require to do that. All right, now we'll have the first point to be explained here. Even though X may know of a path, say XCY, you have got XCY. Okay, so through X, if you send a packet to X has the reachability to Y. That reaches network Y, it will not advertise this path to B. X knows how to reach Y because X is connected to the ISB autonomous system C, and Y is a customer network which is connected to C. This is the scenario, right? Now X knows how to reach Y, but X will not advertise this information to the autonomous system B. The reason is, if B knows that the packet can be reached by Y, then it may go for the hot potato routing. All right. Okay. So it may go for the hot potato routing. Now X has to unnecessarily load the carry this packet, which is not required. All right, so this is an example for the policy. Okay, and the rule of thumb followed by commercial ISPs, for instance A, B, and C. Any traffic flowing across the ISP's backbone network must have either a source or a destination in network that is customer of that ISP. How can I explain this? For example, W has got a packet to be sent to Y. Okay, now you can see from autonomous system B, which is ISB network, W is reachable, Y is also reachable, right? Y is reachable through C, W is reachable through A. Now, when a machine or no, the network in W has a packet to be sent to the network Y, when it is forwarding this to the autonomous system A, this autonomous system cannot forward this to autonomous system B, in other words ISB here. Okay, because this will not forward the packet to C so that it can be sent to Y. Neither Y nor W are the customers of B. So autonomous system B will not involve in this routing process, because it will think it's not my cup of coffee. Why should I bother? It is his business, right? So W has to rely on the A and C because they have got their customers. All right. Similarly, if there is, assume that there is another network which is connected to C, okay, which has to forward something to probably X. So you cannot forward it to A because that particular customer is not the customer of autonomous system A. But whereas X is customer of both, so anything to be given to X, C, B, both of them will respond. Okay, so these are some of the policies which are available in BGP, not all. So I would encourage and urge every one of you to read the textbook which I have mentioned at the start of this class, where Internet Routing Architecture by a Cisco Press book. All right, so that's all from me, and I stop sharing.